Donikian. I'm the founder of Navisens, and I'm here with my team today, and we'll be giving you a short demo, so you'll see them walking around. Okay, so what problem is Navisens solving? Well, today, almost everyone pretty much has a smartphone, and these devices are extremely capable, but they fall short on one thing, and that's location. Specifically, location in urban areas or indoors. And what you see here ends up being a common occurrence when someone's trying to find you inside a building, or when you're trying to locate a service inside a building. And that's mainly due to the existing location technologies. Technologies like GPS, Wi-Fi, Bluetooth, cameras, and other kinds of beacons. These are all based on installation of infrastructure and maintaining that infrastructure. So the problem with that is any environment that you go to, you have to visit that environment firstly. You have to install some infrastructure, and at times you may even have to calibrate that environment. Take some readings, store them, and so on. And the big issue with that is, of course, the time and money and the resources that are required to do that. And secondly, even when you do that, generally to get some reasonable performance, you have to install a large number of sensors, and if the environment layout changes, or there's an event with a large group of people, such as this one, it can throw off some of those calibration or fingerprinting that you perform. So this is where Navisens comes in. And we describe our location technology as the first true mobile location technology. And by that I mean our technology doesn't rely on any infrastructure for it to locate. It doesn't require any kind of external sensors, no GPS. We don't have to have any Wi-Fi calibration or installation of any sensors. All it needs is the mobile phone or the smartphone that you have. And what we really have this patent-pending location platform where all we need is a smartphone with inertial sensors. And we call our technology motionDNA. It processes the sensor data from accelerometers and gyroscopes to give you a 3D motion and a position. Our location platform, of course, also integrates with existing services like GPS and Wi-Fi, so you can still continue to use investments made in those infrastructure systems. But because ideally our core only requires your phone, it means we can do some amazing things. And it also means we can pull out some really high-resolution location and heading, so I can have some really powerful location analytics, unlike anything seen before. And then so, the big reason for requiring mobile location, right, is because we actually spend 90% of our time indoors. So every time we have our smartphone with us, most of the time we're indoors, trying to locate our friends or socializing, using services. And of course, for outdoors, GPS is really the dominant sensor, but it wasn't designed for urban areas. And of course, the number of smartphones is increasing, and it's set to double over the next 3 years. But not only is the number of smartphones increasing, but location-based services are increasing. So what that means is everyone who uses an app or a service on a phone is becoming to expect that their location will be used to give them some better advantage or some better service. And these are some key points. So before we do a demo, so basically what our technology does is it allows you to locate without having to have the overhead of infrastructure installation. You don't have to calibrate or fingerprint an environment. And what that means is you can locate in an environment that you have never visited before, which is extremely important. If we had a visit to France or in the orange buildings, we should not have to have a calibration done in that building, just like if you come and visit Runway. You should be able to locate. And additional to that, we don't have any problems when you have a crowd of people surrounding you. It's all internal to the phone sensor. And one thing that is useful as well, if you're in an area which doesn't have cell coverage and it's out of service, our technology will continue tracking. All right, so we'll switch to a demo to give you a quick look. So if you can see, this is Mitesh, a member of my team. Now, as he walks around, you'll see me standing there in yellow. Now, as he walks around with his smartphone, you can see that we're tracking his position and is heading to really fine precision. It actually tracks at a very high resolution. We're just streaming it a lot slower through Wi-Fi here. And you'll see, Mitesh, why don't you go in the igloo? So it looks like, hopefully when the connection, there it is. So, all right, so you can see while he's in there, we can see what direction he's facing. You can see exactly what he's doing, whether he's stationary, whether he's moving. And this kind of information is extremely valuable to build up analytics and services for indoor environments. And to do this, we don't have to install any kind of sensors inside the building. So now that we did this, we didn't have to install anything inside right away. So no matter what environment you go to, you'll be able to locate yourself. And then now you can see Mitesh is just walking through the back and coming back up to the front. And all of this is just done internal to the phone using our technology with no other references. Thanks, Mitesh. And that's about it. So looking forward to any questions.
So you have to recalibrate based on GPS from time to time, I guess?
Yeah. So because inertial navigation is a relative technology, so errors incrementally grow at some point. So you have some small calibrations that you can do. But what that means is you can reduce the requirement for GPS to switch it completely off to save power. So you can just reduce the duty cycle to very low for kind of calibrations. Yes?
Does it work with any kind of device?
Well, every major smartphone in the last few generations, it will work with. So we require 3 accelerometers and 3 gyroscopes. So really like an inertial measurement unit. Yeah, so any smartphone, which is every smartphone on the market today, including the last few generations, has all these sensors. Yep.
Well, what happens if I shake the smartphone or wave it around or it drops to the floor? Is it still like...
You can shake the smartphone around and wave it around. So basically, our location algorithms reject those kind of inputs.
I have a question. Who are you targeting? Individuals? Or are you personal use? Are you targeting corporations for data use?
Yeah, so there's a few different tracks we can go. Ideally, what we would like to do is to give software to have an SDK, so that any application developer or anyone that needs to locate a mobile device can roll our technology in there. And then companies which would like to make use of analytics, like Walgreens or like grocery